This Lincoln is a dynamic speaker. It's not very big, 2.5 inches. And a dynamic speaker consists of some sort of a cone, plastic, paper, or even thin sheet of metal. It's sort of cone shaped or like a funnel. And at the outer edge, around here, it's fastened to a metal framework. Now, on the back side, or at least centered on the metal framework, is a magnet. Anyway, this is a magnet. Underneath the cone is a coil of wire wound around this circle. So it's almost up against the magnet. The coil of wire is brought out to these leads here. If I move this diaphragm back and forth, that coil of wire moves through the magnetic field. If I apply a DC voltage to the coil, the diaphragm moves. If I apply an AC voltage, it moves rapidly. Here's a signal from a function generator. That's a square wave at about 500 hertz, 200 hertz, 1200. If I hook the coil to the oscilloscope and move the diaphragm, if you look at the oscilloscope, you can see some variation there. If I talk into it, you can see my voice. If I lay one speaker on the other and turn the generator on, you'll see the sound passing through the air from the speaker, which is down here, to the microphone, which is up here. I can vary the frequency of it. You see the coupling becomes more efficient at lower frequencies. I can space the two farther apart. I'll include a set of wires that are BNC by clip leads. Those are actually coming to me in the mail. I don't know if they'll be here in time for Christmas or not. I'll throw in a couple of speakers so you can play around with them. So that'll give you something to audibly do with both your function generator and your oscilloscope. I'm going to send you a couple of these BNC by BNC cables. And if you need to, I'll send you this T. And if you need to, you can use this to couple these cables end to end. Can't imagine why you do that, but it can be used as a coupling. You don't have to use this terminal. It could be used on your function generator Function generator, get it in here. You could put this to the scope, for example, and this to something else. I don't know what else, but anyway, you can use as a coupler, as a T, or whatever you want. And then I'm going to include this kit of stuff. I don't know exactly what's in here because I don't want to unpack it. I believe it should include one of these boards and one of these power supplies. Now if I can find one, I'll get you a 12 volt wall transformer or wall supply that plugs in here. This is actually 2 power supplies in one, but let's talk about the board first. This row of holes, the whole way down, are all connected together, as is the second row in, all connected together. Same thing over here, all connected together. Second row is all connected together. Here we have 5 holes. These holes are all connected together. These 5 holes are not connected to anywhere else on the board. They're just together. 5 holes. 5 holes over here. They are not connected together. These 5 holes are connected to each other only. I don't know what's in this little kit of parts. There's a bunch of resistors and stuff. I'm going to put in some 555 timer chips. These things are older than your mother. They go back quite a ways. And one corner is marked, on these one end is marked, as well as one corner. You'll see what I mean. There are 4 little pins on each side, and they are numbered from the mark 1, 2, 3, 4 down. On the other side, marked 5, 6, 7, 8. Well, they're not marked, they're numbered. You take an integrated circuit like this, for example, 555, and you bridge this divide. Now these legs are a little bit splayed out, a little bit crooked. First you need to make them parallel. Then it should plug in like this. So pin 1 is up in this corner. These 4 holes that are empty are connected to pin 1. And so on 2, 3, 4, 5, 6, 7, 8. So you got 5 holes here. One of the 5 holes is occupied by the legs of the integrated circuit. You can connect parts to, say, pin 4 by plugging small wires in here and connecting them either to other connections on the IC or to other places on the board, or to one or the other of the power supply rails. In other words, that's what they're supplied for. Normally, plus and minus are red, and here it's blue. So if I apply a plus and minus voltage here, I can pick it up anywhere I want down here. That's where this little power supply comes in. It plugs in on one end of the board, and then depending on where these switches are, you will have 3.3 volts or 5 volts or both on the power supply rails. I recommend leaving the switches set for 5 volts. With an NE555, which is a timer chip, a pulse generator chip, whatever, and all of this, you should be able to Google or do a search on 555 timer and get thousands of little test circuits that you could build and look at on your oscilloscope. I did find a little wall power supply here. I don't know if you can see it, but there's a red LED here that just tells me that you're powered up. So now we have 5 volts available here, plus on the red, minus on the blue. It's marked at each end, and this power supply will provide that. This is Tuesday evening. I don't think I'm going to make it for Christmas, but this third package will contain all the catching up stuff.